Forget what you think you know about black holes. It's not just a cosmic vacuum. Falling in isn't just about being crushed. It's about witnessing the universe break. The reality is stranger and more terrifying than any sci-fi movie. We all feel small sometimes, wondering about the big cosmic questions, the ultimate limits, the fear of the unknown. Black holes embody that ultimate unknown, touching our deepest anxieties about existence. Some say it's simple. Fall in, you get spaghettified. Game over. But that misses the insane journey. Today, we dive deep into what really happens. Mind-bending visuals, time warps before the edge, and physics-shattering chaos inside. Stick with me, and you'll grasp the true bizarre nature of these cosmic monsters. Ready to plunge? All right, let's tackle the black hole. Imagine a massive star collapsing under its own weight into an impossibly tiny point. Gravity becomes practically infinite. The universe's ultimate vacuum cleaner where normal rules don't apply. This isn't just suction. The gravity warps space and time itself, like a bowling ball on a trampoline, creating a deep well. It's less a hole, more a cosmic whirlpool, distorting reality. Essentially, it's a star's ghost. Infinite density, gravity trapping, even light, twisting space-time. But how are they born? That story is just as fascinating. How are these beasts born? Starts with a heavyweight star, maybe 20 times our sun's mass. It fights gravity with fusion, but fuel runs out. Fusion stops and gravity wins, collapsing the star catastrophically. This implosion triggers a supernova, blasting outer layers into space. The core keeps collapsing into a singularity, an infinitely dense point. That's the birth of a stellar black hole. Stellar black holes are common, but there are also supermassive ones at galaxy centers, like our Milky Way's Sagittarius A*. Scientists also seek intermediate ones. Different sizes, different origins. But what are their actual parts? Let's dissect this monster. It has regions, the event horizon, and the singularity. But there's more, like stuff swirling around it. The event horizon, an invisible boundary. Cross it, and there's no return. Ever. Not even light escapes. Inside lies the singularity, the core where mass crushes into zero volume, where physics breaks down. It's the ultimate unknown. Before the point of no return is often a light show, a blazing hot accretion disk in the photon sphere just outside the horizon, where light can orbit. Now, that event horizon. What makes it the point of no return? This infamous event horizon isn't a physical wall. It's an invisible edge defined by gravity. Drift past it, and it's a one-way ticket, no turning back. Why so final? Escape velocity. Near a black hole, gravity is immense. At the horizon, escape velocity exceeds light speed. Since nothing travels faster than light, nothing escapes. Space-time itself flows inward faster than anything can swim out. From afar, things get stranger. Due to time dilation, you'd never see something cross. It would slow down, dim, and freeze forever at the edge. For the falling object, the crossing might pass unnoticed. But what happens before that plunge? Buckle up. The ride gets weird long before the horizon. Gravity goes berserk, getting exponentially stronger. Imagine 1,000 suns pull in a tiny point. Your ship needs impossible engines just to pause. Your view warps. Gravity bends light intensely. Stars behind might duplicate or smear into arcs. Light ahead blue shifts, light behind red shifts. The cosmos becomes a bizarre panorama, and time, it does a slippery dance. For a distant observer, your clock slows down as you approach. You seem to move in slow motion. For you, time feels normal, but the difference is real. This temporal weirdness is just a taste of the physical forces coming next. Now, spaghettification. Sounds cartoonish, but it's terrifyingly real. Gravity gets stronger, closer. Falling feet first towards a smaller black hole, the pull on your feet becomes immensely stronger than on your head. This difference is a tidal force, like Earth's tides, but insanely amplified. This isn't a gentle stretch. Forces rip you apart, atom by atom, often before the horizon for smaller black holes. You're stretched long and thin like spaghetti, hence the name. Pulled like cosmic taffy, a brutal display of tidal forces. So you're stretched into oblivion. But what about time? We know it slows for observers, but what's your experience? Does time stretch too, or does something stranger happen? While you're potentially becoming spaghetti, time goes haywire. From your friend's distant view, as you approach the horizon, you slow down, slower, till you seem to freeze at the edge, fading forever. They never see you cross. But the kicker, for you, falling in time feels completely normal. Your watch ticks normally. You experience the fall, spaghettification, and crossing the horizon in what feels like ordinary time. A total mismatch in perceived reality. Wild, right? Frozen for the universe, yet experiencing your own timeline. If time feels normal, but the outside universe fast-forwards from your view, what would you see? What's the view like falling in? Forget postcards. Light warps like crazy. You see streaks, arcs, multiple images of stars. The cosmos turns into a psychedelic painting. Looking forward, you see a growing circle of blackness. The event horizon. Around it. Bizarrely, you might see the entire universe concentrated in a shrinking area behind you as light bends. The sky folds in on itself, near or just past the horizon. The view likely changes dramatically. Does the warped universe wink out, absolute darkness, or a bizarre light show from broken physics? What really happens to light, space, and time inside? You've slipped past the event horizon. Welcome to where our maps of reality fail. Inside, known physics unravels. Einstein's general relativity predicts infinities at the center. Usually, a sign a theory is incomplete. Here, general relativity clashes with quantum mechanics, unimaginable mass crammed into subatomic space. Our theories break down, giving conflicting answers. It demands a new theory of everything we don't have. So, honestly, we don't know for certain what happens inside. It's the universe's greatest mystery box. Does space-time tear, fold, cease to exist? All paths seem to lead towards the singularity. But what is that? All paths inside, theoretically, lead to the singularity. All the star's mass crushed into zero volume. Infinite density, gravity, space-time curvature, infinity everywhere. It's where general relativity breaks down. Think of it as a mathematical dead end. Less a place, more an inevitable future moment. But does this infinitely small point actually exist? Many physicists suspect not. Infinities often signal incomplete theories. Quantum mechanics likely prevents true infinite collapse, but how? While relativity predicts the singularity, it remains theoretical, shrouded in quantum gravity mystery. Do you reach it, or does physics intervene, transforming it? Could it be not an end, but a bizarre beginning, a gateway? If physics breaks down at the singularity, what if it's a gateway? Could falling in be a shortcut elsewhere? Enter the speculative realm of wormholes. The idea? Extreme space-time warping might connect to another point in space-time, maybe distant in our universe or another universe entirely. Imagine space-time as paper. A black hole punches a hole. A wormhole connects it to another hole, maybe on a different sheet. Some theories propose white holes as exits. Mind-bending stuff. But this is highly theoretical. Reversible wormholes likely need exotic matter to stay open. Stuff we've never seen. So, while popping into another dimension is tantalizing, is it feasible? Could any tech survive? After all this, could anyone survive falling in? Let's be honest, based on current physics, nope. For stellar black holes, tidal forces shred you before the horizon. For supermassive ones, you cross intact, but escape is impossible. Light can't escape. You can't beat light speed. Sci-fi uses fancy tech. Shields, warp drives, stable wormholes. Great stories. But the forces here involve space-time itself twisting. No known material withstands spaghettification. No engine outruns inflowing space. It's like surviving the sun with an umbrella. The scale is too immense. Maybe future civilizations, understanding quantum gravity, find a loophole. Manipulating space-time, who knows? But based on known physics, it's a one-way trip with a messy, inescapable end. Not a travel destination. We've journeyed to reality's edge. Spaghettification, time dilation, the event horizon, the singularity enigma. Wild right. This knowledge isn't just trivia. It shows the universe's mind-bending nature. Understanding extremes pushes our boundaries. Let it fuel your curiosity. If the universe has such bizarre rules, what about the limits we set? Are your impossibilities truly solid? What event horizon are you afraid to approach? Ask yourself, what cosmic-level curiosity are you ignoring? Mind blown. Want to keep exploring cosmic mysteries? Hit subscribe and ring that notification bell. You won't want to miss the next deep dive. Let's keep pushing boundaries together.